Let's start with a simple idea. A database is essentially an organized collection of information. Think of it as a special container, a digital repository, that holds data in a structured way, with each piece of information carefully placed, making it easy to find and use. It's all about accessibility and efficiency. Unlike a random pile of data, where finding anything is a chore, a database has rules and structure, a defined schema, turning chaos into order. It brings clarity to what might otherwise be overwhelming. Imagine a box of unsorted photos, a jumbled mess of memories. Finding one specific photo is tough. It's like searching for a needle in a haystack. But if you use labeled photo albums, carefully categorized, it's easy. You know exactly where to look. Databases work like those albums, but on a much larger and more sophisticated scale, grouping related information together for quick access. This makes data management much more efficient. For example, all details about an employee, a comprehensive record, name, job title, start date, all the essential information are kept together. It creates a unified and easily accessible record. This grouping is the cornerstone, the fundamental principle of how databases function. It's the key to their effectiveness. It lets us ask complex questions, perform intricate queries, and get fast, accurate answers. This is crucial in today's fast-paced world. Databases aren't just for computer scientists. They're not some arcane technology. They're tools for anyone who needs to organize information. They are for everyone. Think of them as digital filing cabinets, electronic repositories, or organized library catalogs. They are systems designed for efficient information management. Their purpose is always the same, a consistent and reliable method. Store information so it's easy to retrieve and use. That's the core function. We interact with databases daily, in countless ways, often without realizing it. They are a silent partner in our digital lives. Understanding this basic definition, this fundamental concept, is the first step to mastering databases. It's the beginning of a journey. They make information work for you, serving your needs, not the other way around. You are in control of the information. The power of a database lies, its true strength resides, in its ability to bring order and efficiency. It streamlines processes and enhances productivity. Whether it's a contact list on your phone or a massive corporate system managing millions of records, the principle is the same. The underlying logic remains consistent. Databases are everywhere, a ubiquitous part of our digital landscape, quietly powering our digital lives. They are the unsung heroes of the digital age. Once you see their structure, understand their organization, you'll recognize them all around you. You'll see them in action everywhere. Let's explore how you're already an expert in using them, even if you don't realize it yet. You use databases every day. In fact, you're interacting with them constantly, often without even realizing the sophisticated systems at play. Often without realizing it. These interactions are so seamless, they've become second nature. Your smartphone's contact list is a simple database. A perfect example of how databases are used in our daily routines. Each person is an entry with fields like name and phone number. Think of each contact as a record, neatly organized and easily accessible. The app organizes this data so you can quickly search and find what you need. It's a streamlined system designed for efficiency. Libraries use databases too, to manage their vast collections and help patrons find the resources they need. Their catalog systems let you search for books by title, author, or subject. These systems are powerful tools for navigating a wealth of information. The database tells you exactly where to find a book and if it's available. It's a real-time inventory system that keeps everything organized. Even your grocery list is a basic database, a way to structure and prioritize the items you need to buy. Items organized by aisle for efficient shopping. This simple organization can save you time and effort in the store. This structure turns raw data into useful information. It's the key to making sense of the world around us. Streaming services remember what you've watched using databases. This allows them to provide personalized recommendations tailored to your tastes. Online stores track your orders and preferences the same way. This helps them offer relevant products and a more convenient shopping experience. When you log into your bank account, you're accessing a secure database of your transactions. This ensures that your financial information is accurate and readily available. Map apps use vast databases to provide directions. They analyze countless data points to find the fastest and most efficient routes. Recognizing these examples shows that databases aren't mysterious. They're part of everyday life. They are the backbone of many of the technologies we rely on. You're not learning something new, just naming a process you already use. It's about understanding the underlying principles behind familiar actions. Databases power the convenience of modern life. They help you organize, search, and retrieve information instantly. They are essential for efficiency and productivity. From shopping to entertainment, databases are the invisible engines behind it all. They are the unsung heroes of the digital age. Understanding this makes the concept much less intimidating. It demystifies the technology and makes it more accessible. Now let's look at how databases are structured. We'll explore the fundamental components that make them work. To understand databases and truly appreciate their power, let's break down their basic building blocks, the fundamental components that make them work. The core component is the table. It's the foundation upon which everything else is built. Think of it like a spreadsheet with rows and columns, a familiar way to organize information. Each table holds information about a specific subject, a distinct category of data. A perfect example is your contacts list on your phone or computer. Inside a table, each row is a record, representing one complete entry, such as a single person's contact details. For example, John Smith is one record. All his information is stored together. Jane Doe is another, with her own separate set of details. Every record contains all the details for that entry, ensuring no piece of information is missed. Columns are called fields, and they are crucial for defining the structure. Defining the type of information stored, specifying what kind of data each column will hold. This could be something like first name, last name, or phone number, among other possibilities. Each field holds one type of data for every record, maintaining a consistent data structure. This structure ensures consistency and organization, making it easier to manage and analyze data. Every record has the same set of fields, ensuring a uniform data structure across the entire table, even if some are blank, indicating that the information is not available or applicable. In our contacts table, as a practical example, each person's record fills in these fields, providing a complete profile. The table, with its rows and columns, provides a clear and organized structure, keeps everything organized and easy to search, making data retrieval efficient. This simple structure, the elegance of its design lies in its simplicity. Tables, the containers of our data, records, the individual pieces of information and fields, the attributes that define each record, is the foundation of almost all databases, regardless of their complexity. It allows for efficient storage, ensuring data is readily accessible, retrieval and management of information, making databases invaluable tools. Whether you have 10 contacts, a small personal address book, or 10,000, a massive corporate database, the system works the same way, providing a consistent and reliable method for data management. This uniformity is what makes databases so powerful, enabling them to handle vast amounts of information. It's easy to add, update, keeping your data current, or find information quickly and efficiently. The logic is straightforward, making it easy to understand and use, but the impact is huge, transforming how we manage and utilize data. With this foundation, databases can handle anything, adapting to a wide range of applications, from a contact list, a simple personal tool, to a global inventory, a complex enterprise system. Next, let's see how different types of databases handle data, exploring the variations in their approaches. Databases come in two main types, relational and non-relational. Relational databases like MySQL or SQL Server organize data into tables with rows and columns. They create relationships between tables, linking, for example, customers to their orders. This avoids duplication and keeps information consistent. If a customer's address changes, you update it in one place. Relational databases are ideal for structured data where accuracy matters, like banking or e-commerce. Non-relational databases, or NoSQL, are more flexible. They don't require strict tables and can store data as documents, graphs, or key value pairs. This makes them great for handling diverse, rapidly changing data like social media posts or big data analytics. Each post or record can have a different structure. Non-relational databases scale easily for web apps with millions of users. Examples include MongoDB and Cassandra. The choice depends on your data and what you need to do with it. Both types are essential in today's digital world. In business, databases are essential. They manage every piece of information a company needs. Online retailers store product details, prices, and stock levels in databases. When you buy something, the database updates inventory and records your order. HR departments use databases to track employees, payroll, and performance. Customer relationship management systems are specialized databases tracking every customer interaction. This helps personalize marketing and improve service. Databases also power business intelligence, analyzing sales, trends, and operations. Companies use this data to make informed decisions, not guesses. Databases turn raw business data into actionable insights. They're not just for storage, they drive strategy and growth. Without them, modern commerce would grind to a halt. Databases are vital in education, managing student information, and more. Every school uses a student information system to track enrollment, schedules, attendance, and grades. Libraries rely on databases for cataloging and managing book loans. Learning management systems like Canvas or Moodle store course materials, assignments, and grades. These systems let teachers and students access everything in one place. Admissions and financial aid offices use databases to manage applications and scholarships. Alumni databases help schools stay connected with graduates. Databases keep educational operations running smoothly and efficiently. They ensure data is accurate, accessible, and secure. In every aspect of education, databases are the backbone. Databases aren't just for organizations, you use them at home too. Recipe apps organize meals as records with fields for ingredients and instructions. Personal finance apps track income and expenses, helping you budget and analyze spending. Music and video streaming services use databases to remember your preferences and suggest new content. Even a simple spreadsheet for home inventory is a basic database. These tools help you organize, search, and use personal information efficiently. They turn scattered notes and receipts into structured, useful data. Databases empower you to make better decisions in daily life. They bring order to your digital world. With databases, managing information becomes effortless. Security is a top priority for databases. Access is controlled with user accounts and permissions, so only authorized people see sensitive data. Databases enforce rules to keep information accurate, like making sure dates are entered correctly. These rules, called constraints, prevent errors and keep data reliable. Indexing makes searching fast, even in huge databases. Backups protect against data loss. If something goes wrong, information can be restored. Organization and security work together to keep data safe and accessible. Without these features, databases wouldn't be trustworthy. They ensure business continuity and protect valuable information. Security, integrity, and organization are the pillars of a good database. That's why databases are trusted everywhere. Databases are the invisible backbone of our digital society. They power everything from your morning weather check to your smart home at night. As we generate more data, their importance only grows. Artificial intelligence and machine learning rely on massive, well-organized databases. Understanding databases is now part of digital literacy. Their structure, tables, records, fields, is simple but powerful. Whether it's a financial transaction or a social media feed, databases make it possible. They enable businesses, schools, and individuals to thrive. Next time you search, shop, or stream, remember the database working behind the scenes. Our digital world is built on their silent, reliable foundation.